thank you everyone for attending my talk. I'm Diego Torres Quintanilla, and this talk is about how 2 Sigma upstreamed its internal goals to JupyterLab 4 and 3.5 and 3.6. Only 3.5 is out so far, but more details on that later. Before we start, a very important disclaimer regarding the content of this presentation. Specifically, this presentation does not include any financial or investment advice. If that's what you're looking for, you're probably in the wrong building or in the wrong YouTube channel. All right, so what this talk does contain is some introductions at the beginning to me, to 2 Sigma, our Jupyter wish list, and QuantStack, our partner in this work. It also includes the details on our partnership's contributions to JupyterLab, namely around performance improvements and real-time collaboration. And I also include why I think this partnership can be a model for small and medium companies to achieve similar things. All right, so as stated, let me first introduce myself. I'm Diego. The arrows above explain why my name might seem so long. I like that both sides of my family are represented in my name, but also Diego Torres is already name squatted by a famous singer that I don't like. My pronouns are he, him. I have been an engineering manager at 2 Sigma for the last year, and I was previously a software engineer for 5 years also at 2 Sigma. Also, PyData is very close to my heart. I previously co-chaired PyData New York City in 2019 and Global in 2020. So aside from questions for this presentation, please come say hi to me in the hallway. If you're also from Mexico, or if you have fun tips for a COVID bicycle boom enthusiast, or if you're interested in helping organize PyData, I'd be happy to tell you all about my previous very positive experiences doing so, and I'd be more than happy to introduce you to the current organizers, who, by the way, are amazing. All right, so before we move on, I'd like to explain what my employer, 2 Sigma, does, and why we care so much about Jupyter. So 2 Sigma is a financial sciences company. We combine rigorous inquiry and data analysis to solve the toughest challenges across financial services. I'm very short. Okay. So 2 Sigma's data scientists spend a lot of time doing research. Today, most of our research happens in Python, specifically inside JupyterLab. Every month, our internal JupyterLab distribution reaches about 500 distinct users, which is about 25% of the size of the whole company. And of course, the heaviest users of JupyterLab are the firm's data scientists, who are hard at work solving those tough challenges in finance that I was talking about. This means that a lot of our productive time is spent inside JupyterLab, which means we really care about every single little detail of its user experience and its performance. And naturally, all of our researchers are also always looking for great ways to collaborate with each other. So a good amount of our internal Jupyter extensions are meant to help our users share their notebooks with each other and generally just collaborate together. But we're also a medium-sized company. We employ around 1,000 engineers, but they're busy doing all sorts of things. They're maintaining data centers, building storage systems, operating services, et cetera, et cetera, et cetera. Realistically, we can't spend too much of our own engineering time contributing to Jupyter. In the specific case of Jupyter, throughout 2022, we allocated about 0.5 full-time engineers of those 1,000 to work on our internal distribution of Jupyter, mostly resolving internal issues. So most of this didn't even go to open source work. But just like Jupyter, there are many, many other open source tools that we rely on at 2 Sigma. And although they really help us boost our productivity, we can't give too much attention to any specific one of them, in great part just because there are so many of them. And so pitching in to contribute to these projects with a small amount of resources can be very daunting, not just for an individual, but even for a small or medium-sized company like us. And I guess the pitch behind this talk is based on the premise that I think this is a relatively common problem. They can make companies like us feel like a small fish in a vast ocean or a vast sea of JupyterLab users and contributors. But actually, if you go check out the list of sponsors for the conference, yes, there are a couple, maybe a few massive corporations, but the majority are really just small and medium-sized companies like ours. And many of them care a lot about at least one niche Jupyter feature or issue, but maybe they feel that they're not big enough to make a significant impact in Jupyter development. So for the rest of the talk, I'll tell you about what I thought was a very fruitful partnership that helped 2 Sigma deliver large contributions to Jupyter. I'll tell you a little bit about what those specific contributions were and why we think this partnership represents a good working model for other similarly sized companies. Okay, so first let me introduce our partner in this effort. This is QuantStack. QuantStack is a team of developers and contributors of major open source projects for scientific computing. These projects, of course, include Jupyter. So throughout the last 2 years, we have been working with them to make contributions to JupyterLab. And this has allowed our own engineers to focus on our own internal extensions, our own internal problems with Jupyter, while QuantStack's experts focus on making improvements to open source JupyterLab that also the rest of the JupyterLab community can make use of and enjoy. So before we go any further, I want to give proper recognition to our friends at QuantStack. These are the actual developers who put actual hands to keyboard to do all of the work that I will discuss during the presentation. So sadly, I don't think any of them could make it to PyData New York City. They're primarily based in Europe. But if you see them on GitHub, a community channel, or some other PyData event, maybe PyData London, make sure to give them your kudos if you care about this work. Or if you'd like to know more about the technical details, also please let me know. I can put you in contact with them. I'm sure they would like to talk more about the details. Or maybe I can just point you to some pull requests if you really want to go into the details. Okay, so enough with introductions. Let me get to the first actual meaty part of the presentation, which is what have we accomplished together. And this is the part of the talk that will be very interesting to you if you're a Jupyter user and you want to learn more about what's up and coming in the newer versions. So throughout 2021 and 2022, we focused on essentially 2 specific parts of Jupyter: performance and real-time collaboration. So let's talk about performance first, starting with some of the bigger pain points that 2 Sigma researchers consistently brought to my team during 2020 and 2021. So the first one being that rendering large notebooks is sometimes a bit slow. So if you've ever had a notebook with 100, 200 cells, you've probably seen this. Also, scrolling around on such notebooks can sometimes get a little bit slow and jittery. It works, but it's not a perfect experience. And again, we spend a lot of time using Jupyter. And also in general, delays in the UI are disruptive, even when they're small. So we're really interested in really perfecting every little part of the UX. We also found that these, performance pet peeves are not really specific to us. And it makes sense that, in general, users want things like switching tabs being very fast. So we knew that the community would receive these improvements really well. So for example, here, I'm showing you 3 open issues on GitHub, which refer to similar problems to what 2 Sigma has, which other users found. So note that they all have a lot of comments and long discussions between users and developers, which I think is also a signal that these are not trivial issues to resolve. Okay, so when we began our work, the very first thing we did was to create benchmarks for the specific operations that we wanted to improve. So these are benchmarks that can be run to test the impact of any PR that is submitted to the JupyterLab project. Or they can be manually run by the developer, of course. We think these benchmarks are not just a good contribution to the JupyterLab project itself. We actually also plan to use these internally to run as part of our CI for our internal Jupyter extensions. So if your organization has similar extensions to Jupyter, they might be a good idea to add to make sure that any improvement that you make to Jupyter internally does not come with drawbacks in performance. And I will explain in a little bit exactly how to read those plots. All right, so on to the actual improvements that were made. So the first one is this thing called virtual rendering. If you're not familiar with virtual rendering, it essentially means that JupyterLab will only have to draw the UI elements that are actually visible in the screen, not everything that is in the notebook. This is very similar to the infinite scroll feature that you see in many social media sites, where rendering the whole timeline doesn't actually require loading every single tweet or post. So why did we do this? Because after this change, rendering time is now just bounded by the amount of visible cells, not the total cell count. And this greatly benefits, obviously, notebooks that have a lot of cells, but also notebooks that have a lot of cells with with complex web elements. So things like interactive plots or iframes. I think one of the issues I showed a second ago was about notebooks getting slow when there's many plotly plots. That is the kind of thing that really benefits from this. OK, so those plots that I showed you before actually show the results before and after virtual rendering. The first one being this, which shows how long it takes to open a notebook with a lot of cells that contain specifically Python code. And you can tell that's kind of a massive improvement. That's going from 4 seconds to a bit over 1 second. This second plot is very similar. It also shows how long it takes to open a large notebook, except that it has a large amount of markdown cells, not code cells. And these two show you how long it takes to switch into a tab that has one such notebook open. So you can see sort of improvements all around. This is all a massive discount to the time you spend waiting for the UI to catch up with you and your thoughts. OK. But as they say these days, a video says more than 1,000 plots. So let me show you a quick video that our QuantStack friend Frederick shot. It's not really important that you're able to read. What's most important is on the left, he has a JupyterLab instance that does virtual rendering. On the right, there's one that doesn't. And you can sort of see the one on the left is kind of already done rendering. The one on the right is, I guess, struggling, but also showing a little bit of erratic rendering behavior while the whole thing actually loads. So obviously, that is not great. I'm going to give it a few more seconds just to give you an idea. OK. All right. So moving on to another improvement that we made together, which was to upgrade Jupyter to CodeMirror 6 from CodeMirror 5. If you're not familiar with CodeMirror, it's an open source code editor for web applications. JupyterLab uses CodeMirror as the editor for every cell. And it's in charge of displaying basically everything that users type into the cells and handles a lot of the complexity around that. So this is things like key binding, source highlighting, and formatting. Even the Vim or Emacs key bindings, those are implemented by CodeMirror. So there's a lot of complexity in that library. And so why did we do this? Well, you guessed it, performance reasons. CodeMirror 6 is much faster than CodeMirror 5. It is, in fact, a from-scratch re-implementation of the whole library, I assume with a lot of attention to performance. It also paves the way for CodeMirror's new accessibility features to Jupyter. So my understanding is that before these changes, Jupyter was not in really good shape in terms of accessibility tests. And now it still has a long way to go, but it has really gone from an intractable problem to a limited set of issues that can now be resolved one by one. And once more, here are the benchmark results that we got for this change, showing that massive improvement in how long it takes to open a very large notebook in both regular code cells and markdown cells. Okay. Yet another problem that we fixed was what we called a misalignment between the protocol used to communicate between the Jupyter server, the browser, and the notebook kernel. So in many of these cases, the Jupyter server is really just an intermediary between messages that go from the kernel to the browser. The most basic example is when you have a kernel that returns cell outputs that maybe contain images or large data tables that then need to be rendered in the browser so that the user can look at those outputs. So the protocol of communication between the browser and the server, which is represented here by a green squiggly line, and the protocol between the browser and the kernel, represented by the purple squared line, was very different. And this was forcing the Jupyter server to deserialize every message, sort of translate it to the other protocol, and then reserialize it. So not like a huge issue, but it was definitely impacting the performance of how long it takes for the kernel to return an output and then you actually being able to see that output. So as part of that collaboration, we simply aligned those two protocols so that now all the Jupyter server has to do is forward those messages along. There's no longer any deserialization, reserialization, translation, or anything like that going on. Things that really benefited from this are not just cells that return large cell outputs, but also cell outputs that have Jupyter widgets that, again, render complex data in visually appealing ways. Okay, one final improvement to highlight that I'm going to go really fast over is this Lumino 2 thing. Lumino is the web component library that JupyterLab is built on top of. JupyterLab is also the main user of Lumino. We upgraded JupyterLab to Lumino version 2. In particular, this comes with the removal of a lot of things that were previously polyfills for ES 2018. Now they're using native implementations, and that just came with like performance improvements all over the place. It also has enhanced performance for some specific components, like the data grid, which 2 Sigma really cares about. Okay, so that's it for performance. Now let me talk about the other area where we focused on a lot during this collaboration, which is called real-time collaboration, or I will be referring to it as RTC throughout most of the rest of the talk. So what is it? You're all probably very familiar with it. Maybe you just haven't heard the term RTC. So it's essentially when you have multiple users all working on a single document, in this case, obviously a notebook. Think of like cursors showing who is writing where, who wrote which comments, who made which suggestions. I'm sure you're familiar with some office tooling that does something like this. So let me walk you through very quickly through 3 contributions we made together in this space. The first one being together we implemented per cell collaborator lists so that you can see who is editing a cell at any given point in time. We implemented a collaborator panel showing who has made changes to the notebook across its history. And we also made the undo, redo history of the notebook to be like to be on a per cell basis, mainly because you can imagine how chaotic this could be if we had many folks collaborating in a single document and Control-C being a global undo. But there is still a lot of work to be done in the RTC space. A lot of the end user experience is now implemented. It's obviously in early stages. It's still a little bit rough, but like the most basic operations in real-time collaboration are now have been pushed. Some of them are unreleased. Some of them are released in JupyterLab. Are going to be released very soon in JupyterLab 3.6, which should be going out probably within a time span of weeks. However, there are some big chunks missing. The main one of them is a comprehensive authentication story. So right now, you can't really deploy real-time collaboration at in your organization, primarily because it won't really integrate with any major authentication systems. What this actually means is, every collaborator will just have this air of mystery, being an anonymous something, and you won't really be able to keep track of who these people are and what changes they made and or the changes that they made safe. There's no authentication, no authorization at all. So raise your hand if you know what that word is. It's not an animal. Anonymous, I don't even know how to say it. Any guesses? It's actually one of Jupyter's satellites. I learned this yesterday. There are actually 80 known satellites for Jupyter, as per Wikipedia. So that should be plenty for a lot of collaborators. OK. So up to this point, I've covered everything I wanted to mention that should be exciting for any Jupyter user that wants to use the latest version of Jupyter, specifically 3.6 and JupyterLab 4. Now let me talk a little bit about how Sigma and QuantStack work together to accomplish these big improvements and how I think your organization can do so too. So first, let's think about this for a second. I showed you this number a little bit ago, which is the size of our engineering organization. I'm sure that many of you thought that I'm a crazy person for saying that we're a medium-sized company. Some of you may be thinking, certainly more than 0.5 of those folks could be working on Jupyter. And the answer is kind of. We do actually want to grow that number beyond 0.5. But the reality is that once we do that, it will still be hard to have this kind of impact in such a large project as Jupyter. Really, the changes that I just described require very large modifications to Jupyter code bases. Some of them are downright re-architecting major components of Jupyter. So doing this kind of work actually requires, in my opinion, going through two very steep learning curves. There's one which is, of course, the technical learning curve of becoming an engineer that is capable of doing such large changes, becoming familiar with the stack. This is a stack that's not super common at Sigma, but that's something we could deal with. It's something we could manage. But there's also a big learning curve when it comes to having the social and the community connections required to make this kind of change happen. Well, we know that improving performance is something that probably everyone in the community just wants to do. It is challenging for an organization like Sigma to figure out which of the possible ways in which you could bring better performance along are well aligned with the community's current goals, the maintainer's current projects of interest, et cetera, et cetera, et cetera. So we don't want to spend a lot of time as an organization building something that won't be able to get merged. And we also don't want to push the community to solutions that the community doesn't want. We obviously want everyone to benefit from the work that we're doing together. Of course, there's always the option of hiring folks that already have this expertise, and it is something that we have done in the past. But trust me, also hiring for this kind of skill is not easy. And really, if you want to start contributing now, this is not really like a good way to start contributing now. It's kind of a long-term solution. So these challenges are why we think having a partner like QuantStack with all of this expertise already in the ranks is really the way to go. So let me tell you a little bit more about how the partnership works. If you're familiar with working with a contracting firm, maybe you've heard the term statement of work. So maybe this sounds very obvious. Diego, why are you mentioning this? What I want to mention here is, there's a statement of work, but it is intentionally not very prescriptive about the kind of work that QuantStack is going to be doing in Jupyter. This represents a really good separation of responsibilities because at Sigma we want to make the performance better, but we don't want to be overly prescriptive. we know that QuantStack is best prepared to figure out the best ways to accomplish that in Jupyter that are well aligned with Jupyter's own architecture and well aligned with Jupyter's community. We also have a process so that internal support issues can be escalated from our own internal employees to open source with the help of QuantStack staff. So we actually have a mostly reasonable pipeline now to go from internal reports in our company Slack, so that an internal engineer can help triage them to QuantStack, and then QuantStack can figure out make some sense out of the issue, maybe have some suggestions in a GitHub issue, and eventually we can have a PR to address that issue, probably also by QuantStack. And that issue over there is an example of that thing working. Another detail that might be interesting is that QuantStack helps to Sigma manage our internal Jupyter deployment. Most importantly, they help us stay up to date with Jupyter, which is very important for making sure that our internal users actually get to use all the shiny new things that we contributed together to JupyterLab. But here is the first important caveat. So far, I have essentially just said, set up a working relationship with a team of Jupyter experts, and they will solve all of your problems. But it's really not that simple. There are definitely some things that your organization is going to want to do to make this kind of relationship work. And the most important one is staying up to date with Jupyter. And although I just said that the experts can probably help you with that, this may require changing some things in your workflow. So let me tell you a little bit about how we stay up to date with Jupyter at 2 Sigma. And the most important thing that we do is to make sure that the set of libraries used to run Jupyter is always completely isolated from the set of libraries used by the kernels. By this, I mean that you essentially want Jupyter and its kernels to be running on completely different environments. And I mean virtual environments or content environments. That way, for example, you can use one version of Jinja or Tornado in your notebooks, even if Jupyter requires a different version. And this may seem silly at first. Do people actually use Jinja and Tornado or other Jupyter dependencies in their notebooks? And the answer to that question is an absolute definitive yes. Here's a basic example. Dask depends on Tornado, and you definitely don't want Jupyter telling you what version of Dask you can use. It's weird. It kind of doesn't make sense. It's like if you couldn't upgrade pandas because VS Code doesn't like it. So luckily, this is nothing new. This is well supported by Jupyter. It has been for a long time. Kernels can be created from things like virtual environments and content environments, which will then show up in the kernel selector when you create a new notebook or a console. For example, you may be familiar with this thing called NV-conda kernels. It's been around for a long time. It essentially lets you see all of your content environments in the Jupyter kernel selector. We have some internal tooling that is very similar, accomplishes exactly the same goal. Most importantly, it guarantees that our users never end up running a notebook with the same environment used to run Jupyter, because then they depend on the same libraries, and that's a recipe for disaster for reproducibility. This separation also means that 2 Sigma and QuantStack engineers can upgrade Jupyter for everyone at the firm whenever we want without breaking their environments, which is really crucial to staying up to date. So here is another requirement for this kind of relationship to work. It's specific to Jupyter, but we found it's pretty important. So we know that internal and open source extensions can really boost the productivity of our users. We've all done this before. We find a great extension that gets us a very niche feature we like, and it dramatically improves our experience. They can also act as an anchor for upgrades. Not all extensions prepare for JupyterLab upgrades in lockstep with JupyterLab. They often take a while after the JupyterLab release is made, which is really inconvenient because it means if you really depend on these extensions, you're stuck on the older version for another while. So this introduces a kind of a very interesting trade-off, which is being up to date with the latest stuff versus specializing your Jupyter build at the cost of that upgrade agility. So I really think that if you want to make this kind of relationship work, you have to lean a little bit towards upgrade agility. There's, of course, always an escape hatch, which is, also send PRs to your favorite extensions. An organization like QuantStack can help you with that. We've looked into doing that, but of course it can also get costly. So the trade-off is still always there. You just add an extra dimension, which is funding. Okay, I think that's pretty much all of the content. So let's walk again over some of the takeaways of the presentation. So the first one, try the JupyterLab for alpha version. I think there's been like 20 or more alpha releases. I guess that's just how the JupyterLab project works. I highly recommend you try it. There is also a 3.6 alpha released in the PyPI as well. Although that one is probably going to both are going to turn into betas probably pretty soon, but 3.6 release I think is going to be in the relatively near future, whereas JupyterLab 4 is probably going to be more of an end of year towards early 2023 kind of situation. But again, I'm not an authority on JupyterLab releases, so definitely check in with the JupyterLab community online if you really want a timeline. All right, another important takeaway, encourage your organization to update JupyterLab frequently. It is good for your organization, and it is good for the health of the JupyterLab project if everyone is using the latest version, because that way bug reports are always much more relevant. And of course, encourage your organization to contribute to Jupyter. It is the main takeaway for this talk. I think that the partnership between Sigma and QuantStack is a great collaboration model. I'm hopeful that it can be useful for other organizations. If you're not sure of what's a good place to start, check out the Jupyter Community Calendar. You can just find it by Googling Jupyter Community Calendar. There's also a link there. I guess at some point the slides will be available. There are weekly team calls that you can join in that calendar. And these calls are open to the public, and the JupyterLab team is really happy when organizations come participate in them and tell them all about their problems because they want to make JupyterLab truly better for everyone. Even some specific efforts actually have dedicated talks. So for example, there is a recurrent call just to discuss real-time collaboration in Jupyter. And definitely consider partnerships to amplify the impact that you can have in JupyterLab. Again, one particular effort that you can always join is RTC. And another important takeaway, going back to something I mentioned at the beginning, definitely consider volunteering next year for PyData or other PyData events like this one. I highly encourage you. I have been very involved in previous iterations and can tell you all about my very positive experience. I'm also happy to make introductions to previous and current organizers who I'm sure will also be very happy to tell you about their experiences. If you're thinking about it, but you're still not sure, here is one very important piece of information. While we're all enjoying the talks, the conference's organizers and NumFocus and James are all thinking, how are we going to make PyData New York City 2023 happen? Who wants to step up to the big roles in the organizing committee? Have we met anyone that could help us next year? That could be you. If you're not sure, there's no harm in asking. Definitely get involved. And finally, Sigma is hiring. The team that made this specific collaboration, it's a software engineering team, is also hiring. If this work sounded interesting to you and you're curious about Jupyter development if you're curious about what Jupyter development at a financial tech company looks like, come talk to me or shoot me an email. It's just diego@twosigma.com. Or if you're curious about other opportunities at Sigma, check out twosigma.com/careers. And that's all, everyone. I'm happy to answer any questions you may have, especially about how our relationship is fruitful.
Just so you know, volunteers get to attend the conference. conference for free, so that's a really great reason to come to be a volunteer. But you have to volunteer for at least half the time.
James.
I have a question about your last slide. Are you hiring people at 2 Sigma to work on Jupyter, and will their contributions be open source? Somebody can actually get paid to work on open source code?
Yeah, so organizations like 2 Sigma contribute to open source all the time. There are no promises on what percentage of your time is going to be dedicated to open source, but there are frequent contributions to open source coming from 2 Sigma, and that's a thing our engineers do.
That's basically a dream job for anybody.
Yes.
What kind of internal extensions do you guys build? Sure, allowed to talk about it.
Yeah, sure. So the question is, what kind of internal extensions do we have at 2 Sigma? So most internal extensions these days revolve around the way we are able to share notebooks internally with each other. So obviously we have internal storage systems that are not commonplace if you're running Jupyter in your own machine. They mostly revolve around that. We also have actually a set of open source extensions called BeakerX. They mostly revolve around specific widgets for rendering tables in cell outputs. So definitely check out, that is called the BeakerX table display. It's just a very sophisticated way to render something like a pandas data frame in cell outputs in a paginated way that you can copy paste into. You can color you can manually color specific cells. Yeah. Yeah, Thomas.
On performance, when you had to align the protocols between the browser and the Jupyter and Jupyter kernel, you have to pick one of the protocols to.
Oh, that is an excellent question. I don't know too much about the details on that one, but I can definitely put you in touch with the developer that did. Yep.
I know you're not dedicated Jupyter, but to your knowledge, after performance and real-time collaboration, what is the next big priority for them?
For the Jupyter team, I really don't want to speak for their priorities, but what I can tell you is that probably 2 Sigma will continue to focus a lot on performance-related issues. I think also one particular interest of me, we haven't crafted like a long-term plan for Jupyter for the next year yet, is the way our kernel manager works. I think could be a little bit better. So we really want to look into how to plug in custom kernels in Jupyter. Cool. James.
Do you require your users to use Jupyter, or are they free to use that among any other tool they want to use?
Excellent question. So actually, 2 Sigma is pretty liberal as to what its data scientists are free to use. Granted, for notebooks, the vast majority of researchers using notebooks are on Jupyter, but people are really free to choose the tools that they want. We do know some users use VS Code to work with notebooks. I'm personally also excited to see another open source project delve into working with notebooks. But yeah, we're happy to see our users really take full advantage of the open source ecosystem. Yep.
So has real-time collaboration made version control any more complex for notebooks?
Oh, excellent question. I'm not really sure. But it's definitely something we can forward along to the team. Oh, yep.
So do you guys have a central Jupyter Hub sort of deployment that everybody uses?
We do have an internally hosted Jupyter instance, but the vast majority of our users actually use Jupyter in a similar way to what you would do in your personal laptop, where they just run it locally on their development host. We do have some control over that environment that they're running from. They don't really they don't do conda create and then conda install Jupyter. That's sort of done for them. We just have an environment that they can always use to launch it. Yep.
Does that apply to real-time collaboration use as well?
So,
would that be done with your Jupyter Hub?
So I think the first goal for real-time collaboration internally would be on like the hosted solution. But yeah, I think like, it shouldn't matter where it's running. Really, real-time collaboration is also meant to support, like, when you're running it locally, there should be people that are able to connect. Obviously, authentication can maybe get a little bit tricky in those cases. But yeah, like I said, the authentication story is still yet to be written. Yep, Thomas.
How is real-time collaboration being received by data scientists? Like when I think with your notebook, people could execute styles in different ways, and you have like 4 people on a notebook.
Yeah. So the reason we started real-time collaboration at Sigma is that our data scientists were asking for it. I think to some degree it's kind of like hypothetical. Like there haven't been like many. I guess there are some cases now of like real-time collaboration in notebooks in other notebook products by other companies. But I think when the initial asks were made, like that didn't exist. So the way we see it internally at Sigma, it's still a little bit experimental. We're not really sure. Like we know people hypothetically want it. We know probably some of our internal users have tried the other solutions and they still seem interested. But really, like we haven't seen that. Letting it out in the wild and seeing what people think. But I know the JupyterLab folks recently did a very extensive test, or the QuantStack folks did a very extensive test with another client of theirs that is very interested in this kind of work. So I'm pretty sure they have a lot of input at this point. I see a question over there.
As part of the real-time collaboration, have there been any discussions of commenting or discussions within the notebook?
Yes, there definitely have been. I have not been keeping track of that specific PR, but there is definitely concrete work that's been done so far to enable commenting. I don't know yet if it's being merged, and I don't know yet if it's going to be in JupyterLab 4. But I was actually fishing for that PR yesterday, so if I find it, come and find me. I can pass it on to you. Yep.
You think on the other question, maybe one option that might help is if the code is real-time collaborative, but the executions are separate?
Yeah. So I think what's in scope right now is like, also the execution, but it's it's an interesting question. I don't know if it's been tried. Cool. I'll be around if anyone has any more questions, and if you're interested in any of the other things I mentioned during the talk, like hiring.